Welcome back, Physics 30. This is the third and last installment of the Universal Gravitation booklet. So we looked at the universal gravitational equation, and then these two equations that relate the weight at two locations and gravitational acceleration at two different locations on the Earth or some other planet. Okay, number 17. How does the force of gravity change as you get closer? So we know what happens when you go outside the Earth. It gets smaller, smaller, smaller. What if you were to somehow teleport inside the Earth? Now, if we take a look here, there's a lot of mass on pulling you in towards the center, but there'd also be a lot of mass pulling you back outwards. The outer part of the Earth's crust would pull you in that direction too. Until if you theoretically could get to the center of the Earth, you'd be pulled equally in all directions. And I suppose if it was hollow, you would be somewhat weightless in the center there, being pulled in every which direction. What does the gravitational field strength and other planets depend upon? Depends upon the mass and also how big that planet is. What is the radius of it? Okay, so that's it, folks. We just have the vocab to look at here. So field in general is the region in which a force is experienced. So if we're looking at the Earth, we experience forces towards the center of the Earth, as illustrated here by these force vectors. Force is a push or pull exerted by an object. So here I use these vector lines of force here to illustrate what's happening to an object at the surface of the Earth. Mass, measure of the amount of stuff in an object or matter in an object. Same throughout the universe. So to technically measure your mass, you could have a balance situated on a planet wherever you're from, assuming that we have some gravity pulling downwards here. There'd be an equal force here pulling down once your mass is completely counterbalanced. So you could take a look at how many G's or kilograms is here, and that would be your equivalent mass. Weight is not a measure of mass, it's a measure of the gravitational pull that's being exerted on you. So the force of gravity pulling downward. So this scale would read differently on Earth or Moon, but of course scales on our planet are calibrated to give us the mass for assuming we're at the surface of the Earth. So they're calibrated in such a way that we can actually get our mass reading. Gravitational field strength is simply the force of gravity exerted on a 1 kilogram mass. So the gravitational force here, gravitational field strength, they are the same thing. Okay, so there you have it. That's the end of the Universal Gravitation booklet. See you soon.